We are going to look at reflections. Look at these two rows, the same reflection. And what do you notice? What do you notice? Talk to your shoulder partner. What do you notice? Who wants to answer? Jason. Okay, so there's a reflection of the mountain on the lake. So right here, here's the mountain, and you can see the mountain down here. Who else? Who else? And really kind of focus on this one, what they're trying to show you with that mountain. Adrian? Okay, it's backwards, it's flipped, right? The mirror image. Anybody else? Kind of look at, you see right here where the mountain ends and the lake begins, and then what we have here? And then look at these lines. What do you see? Yes. Same distance from the line. Okay, same distance from the line. So let's look at what they give us here. Every point is the same distance from the central line right here. Here's the central line. Every distance is the same. So if you have this point right here, it appears to be the same distance as this point to the line. And the same like up here. This point to the line is the same as this point to the line. And the reflection is the same size as the original shape. So this appears to be the same size. So we are going to look at reflections, and a reflection is a transformation that flips a figure across a line. The line is called the line of reflection. Each point and its image are the same distance from the line of reflection. Just to review, because we're going to make some corrections to these notes. Draw the line of reflection. I don't draw, I highlight. I highlight the line of reflection. It just kind of gives you a central point of where to go, what to count towards. And then where it says draw a perpendicular line, I don't draw a perpendicular line, I count. I count from the point to the line of reflection. Determine the distance. How many units? How many units? And then I don't continue the line. I count again. I count to the other side of the line of reflection. And then you plot the point the same distance away from the line of reflection. Okay, whatever you counted, that's how many spaces you plot that next point. You label it. Remember, you need the prime mark. And then repeat until all points are plotted. So we're not going to draw that perpendicular line. We're just counting towards the line of reflection. But I do recommend highlighting, especially when we get to tomorrow. The biggest mistake I see is students going over the wrong line of reflection. So if you highlight it, it kind of forces you to go to that. And then you have this. This is the rule that we'll be talking about in a minute, the algebraic rule. All right, not this one. This one. You have this one, correct? So at the top of that graph, I want you to write the rule in words. reflection across the y-axis. So on the top of that graph, write the rule in words. Where's your note sheet? No, the one you just picked up. Right? Reflection across the y-axis. All right, so now, if you have a highlighter, take it out, and let's highlight the y-axis. If you don't have a highlighter, I would take out a red pen and go over the y-axis with your red pen so that you're kind of forced to go towards that line. So what you do is you take a point, start anywhere you want. You take a point and you count towards the line of reflection. So how many spaces is it? 1. So you just go one more onto the other side, plot the point, label it Z prime. Take the next point, count to the line of reflection. 1, 2, 3, 4, and then just count to the other side. 1, 2, 3, 4. Plot the point, label. So this one, you just count 1, 2, go 1, 2 onto the other side, Y prime. And then you connect your points. Straight edge. And everybody has a straight edge. You either have your ID card, an index card, the edge of a folder, ruler, something. Something you can use as a straight edge. Okay, now we need to write the algebraic rule. So, in order to get the algebraic rules, I'm going to write the ordered pairs so that we can kind of discover this algebraic rule. So the ordered pair for here is 1, 4. And this one is negative 1, 4. Negative 1, 4. Okay, I'm going to write the ordered pair here. This is 4, 2. This one is negative 4, 2. And then this one is 2, 0. And this one is negative 2, 0. So, talk to your shoulder partner. What do you notice when we look at one ordered pair compared to from the pre-image to the image? From the pre-image to the image. Okay, go. Did they include you, Anthony? Include. All right. Would like to share their observation. One person always wants to share. Come on. Very. Okay, the x turns negative. What about the y? Stays the same, right? The y stays the same. We went over the y-axis. The y stays the same. It's on the same level. But the x turns negative. So our algebraic rule that you're going to write right below the graph is, it starts the same. xy becomes, which one went negative? X, the y stayed the same. So we went over the y-axis, the y stays the same. We went over the y-axis, the y stays the same, the x becomes a negative. Did you write that down? Okay, let's do another one. Write this rule above that next graph. Write the rule above the next graph. Reflection across the x-axis. And then which axis are we highlighting? The x. So highlight the x-axis. Okay, pick a point. So let's take y. And let's count. 1, 2, 3, 4, and then go 4 onto the other side. 1, 2, 3, 4. Y prime. And then the H. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. H prime. And then the M. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. M prime. And then connect your points. Let's look at the ordered pairs for this one. My original one down here would be 0, -5. And then the H up here, the H prime, is 0, 5. The Y is 0, -4. And then this one is 0, 4. The M, 3, -5. And then this one is 3, 5. Talk to your shoulder partner. What happened to these ordered pairs? All right. Bryce, what happened to these ordered pairs? Well, say it a little bit differently. X stayed the same and the Y became what? Well, what are 5 and -5? What kind of numbers? Inverse, opposite, so it became the opposite. So, our algebraic rule, when you go over the x-axis, the x is going to stay the same. The y is the opposite, so it's -y. So the key to writing the algebraic rule is whatever axis you're going over, that variable just stays. Right? Pay attention, please. If you're going over the x stays the same. And the y is the negative. If you're going over the y stays the same, the x is negative. Okay? So that's the key to whatever axis you're going over, that variable stays the same. The other one's negative. Do these two. Write the rule. The rule is right here. Reflection across the x. Reflection across the x. And then write the algebraic rule for both. On these ones, I'm going over the x on both of them. Here's x, here's x. And so this is 4 away, z prime, 1 away, v prime, 2, c prime, 4, and 4, w prime. The biggest mistake I see is students trying to just eyeball the new image and not, actually counting. I see a lot of letters reversed. Because you see how it's P on top and then N? I see a student like go, oh, I know these points are right there, and they put the P right here. But that's not where the P goes, because the P is 3 away, so it's down here. And then this is the N prime. And then X prime. And then let me write the algebraic rules. So xy becomes, and then this went over the x, so the x stays the same, the y is the opposite. And this one's the same. xy becomes, it went over the x, so the x stays the same, the y is the opposite. Whatever axis you go over, that variable stays the same. Now, oh, not this one. Let's look at this one. So on the back side, you have this one. Write this algebraic rule on top. Just write this algebraic rule on top. And then see at the bottom, down here, where it says algebraic rule down here. Cross off algebraic, cross this off, and put words. Cross off algebraic, and then words. Words rule. Because words do rule. Math rules. All right. In here, they give us the algebraic rule. What axis are we going over? X, because that's the one that's left alone, right? So I can write that rule in words. Reflection across the x-axis. Oops, x-axis, not a-axis. Reflection across the x-axis. So which am I going to highlight? The x-axis. And then plot your points. And label with the prime mark. What happens if what? That's tomorrow. So, and I'll go over that on. I'll repeat his question on the next example. Okay, so we already wrote the rule in words. We did that first because we translated our algebraic representation into words first, and then we graphed. So we're done with this one. Okay, look at this one. And just write this rule at the top. And again, down below where it says algebraic, cross off algebraic and write words, rule, words. Tell your shoulder partner which axis you're going over. the y. That is correct. And remember, if you're ever confused about how to exactly write that rule in words, look on your paper. They're all over the place. And then reflect it. So you should have went over the y-axis. Reflection across the y-axis. All right. So the question, Ethan's question was, what if I had a figure like this and I'm going across the x-axis? What does that look like? You'll find out tomorrow. Okay? So tomorrow we'll be taking a shape like this and actually going across the x. But some of you can probably guess what it's going to look like. But that's why I have you highlight. Because when you do that, when you go over the x-axis on a shape like this, it gets a little bit confusing. So that's why I have you highlight. All right, now we're going to do, oh no, not this one. There we go, this one. We're going to do the rule in words and the algebraic rule. So the easiest to start with the rule in words. Look at this figure. Which axis would you highlight that it went over? Which axis? X. You would highlight this. Let me change that color. Let's see what this one looks like. That looks better. All right, so you would say reflection. Across the x-axis. And the algebraic would be which one stays the same? X. X. Oh, this is x-axis. Sorry, I wrote the wrong one. There. X negative y. All right? So when they give them both to you, they're just asking you to write the rules. They do the same thing for this one. When you're done, do the bottom left, Sage and Scribe. That's it. You're not going to do Sage and Scribe. I just want you to do it. I want you to go, what does it say? I want you to go over the Y. Go over the Y-axis on the bottom left. Okay, this one looks like this. Flexion across the X, Ethan. And it should have X negative Y. Okay, do you check this one out? And then this one, I just want you to do this one. Don't do this one. and go over the y. And write the algebraic rule. Okay, you're going across the y, and it should look like it should look like that. Your algebraic rule should look like that. Any questions? Pretty easy, right? Well, I shouldn't say easy. Scale of 1 to 10.
10.
10 is the hardest.
11.
1 to 2.